Okay, class, today we are going to be talking about using the unit circle in reverse. So we're going to do backwards than the way we did it in the last lesson. I am going to show you how to use the calculator sum and then apply it with some word problems. So first off, we do have the unit circle here, and it says use the unit circle to find the desired angle. So the given. So there's two things that we're going to read from this given here. One, pi over 2 is a radian. So when we're told we want our angle, okay, so we want our angle to be between greater than 0 and less than pi over 2 or equal to. So we're looking for an angle. So first off, it says solve for theta. So we want to find an angle, because theta is always going to be an angle. And since we're given this restriction here, this is given in radians. So that is a hint that we're going to want our answer in radians. So if theta is between 0 and pi over 2, then we are in quadrant 1, because that is where the angles are greater than or equal to 0 and less than or equal to pi over 2. So our answer theta is going to be some angle in quadrant 1. So it says solve for theta, so find the angle given that cosine of theta is 1/2. So if you remember, cosine of theta is defined to be x over r. And since it's on the unit circle, our r equals 1. So essentially cosine of theta is x, because our radius is 1. So we're looking for the x-coordinate on the unit circle, and the x-coordinate is 1/2, because cosine is defined on the unit circle as the x-coordinate. So here I see an x-coordinate of 1/2, and the angle that goes with it is the 60-degree angle over the pi over 3 angle. And since we want our answer in radians, I know that theta is pi over 3, and that is our answer. Because cosine of the angle pi over 3 is 1/2. You go up to pi over 3, you find the cosine, which is the x-coordinate, and you got 1/2. Okay, so solve for theta for the second part. So again, we want to find the angle, given that cotangent of theta is 1. Well, on the unit circle, cotangent is x over y. So I'm going to look for the ratio of the x over the y and see if I get 1 out and determine what angle is it. So I'm going to take my x over my x over my y, and I see over here for the 45-degree angle, if I take my x-coordinate, root 2 over 2, over my y-coordinate, root 2 over 2, the same thing over the same thing reduces to 1. So that is at the angle theta equals 45 degrees, or in radians, pi over 4. Okay, so cotangent of pi over 4 is 1. Okay, so that is using the unit circle in reverse, essentially finding the angle given the x or the y coordinate or the ratio. Okay, so now what we're going to do is we are going to move over to the calculator. So some things that I need to mention. One, we're only using our calculator if the given angle is not on the unit circle. Okay, so 58 degrees, pi over 12, and 3 are not on the unit circle. The unit circle angles are pi over 4, pi over 3, pi over 6, pi over 2 angles, not the pi over 12 angles. And then in degrees, it would be like multiples of 30 and 45, so not 58 degrees. Secondly, we're going to have 2 modes on the calculator. So for our mode, and I'll show you how to change the mode, we have degree mode, which is D, E, G, and then we have radian mode, which is R, A, D. So if it is a degree, then we're going to use degree mode. When it's a radian, and a radian is anytime we do not see a degree symbol, so I don't see a degree symbol, so I know it's going to be a radian, so we need to be in radian mode. And then for the third one, cotangent of 3. Well, it's not 3 degrees. I would write 3 degrees. There would be a degree symbol if I meant degrees. So this is 3 radians. So this is going to be in radian mode. Now remember, if I said like find cotangent of pi, pi is 3.14 radians. So cotangent of 3 is very close to cotangent of pi, because 3 radians is almost the same as 3.14 or pi. Okay, so we are going to move over to the calculator. So you should have yours out, and I will show you how to adjust the mode. Okay, so now I have my calculator up in front of me, and I turned it on. And what we're going to do is we're going to have to adjust the mode, because we're going to have to flip between degree mode and radian mode, and you are going to have to understand when you need to be in which mode. So we're going to press the mode button up here, and we can see that we have radian and degree mode. So I'm going to go switch over to degree mode. So I use the arrow keys to arrow over to degrees, and you press enter. So then it should highlight now on degrees. So now I know I'm in degree mode. So I'm going to quit by pressing second and then mode, because you see blue, it says quit. Okay, so now I'm in degree mode, so I can simply type sine of 58. You don't even have to close your parentheses. You may close your parentheses, but this would be sufficient. And then you press enter. So sine of 58 degrees would be 0.84. Let me pull this up now so I can write on it. So we found that sine of 58 degrees is 0.8480, and we're going to go ahead and round to 4 decimal places unless it's stated otherwise. So let's go back to the calculator, and we're going to have to adjust it to radian mode to find secant of pi over 12. And moreover, if we want to find secant, we are going to have to use these reciprocal identities. So for secant of some angle, pi over 12 in this case, is 1 over cosine of that angle. So I'm going to have to rewrite this as 1 over cosine of the angle pi over 12. And then I'm going to type this into the calculator to get a decimal answer. So let's go back to the calculator. Okay, so now we are back at the calculator, and I want to find secant of pi over 12. So using the reciprocal identities, it's 1 divided by cosine of pi divided by 12. So to get to pi, you'd use second, and then the pi symbol divided by 12. And you don't have to close your parentheses. And so 1 over cosine is how we get in secant. So you do need to know those reciprocal identities. So right now, if I pressed enter, I'd get the wrong answer because I was in degree mode for the previous problem. So I'm going to go back to mode, and I'm going to go down and press enter on radians and wait for it to shift to radian, so that I'm going to be in radian mode. And I'm going to quit. Okay, so you can either switch your modes before you start the problem or at this point, just as long as you do it before you press enter. But now my calculator is in radian mode, and if I press enter, I get 1.035. So again, we are going to be rounding to 4 decimal places, so it's 1.0353 would be 4 decimal places. So finally, cotangent, we need to be in radian mode, which our calculator should still be in radian mode, but to use cotangent, since our calculator only had sine, cosine, and tangent buttons, we're going to rewrite it using the reciprocal identity. So this is equivalent to 1 over tangent of that angle, 3 radians, and so this is how we're going to enter it into our calculator. And let's go ahead and go back to the calculator. Okay, so it's 1 divided by tangent of 3, and remember it's 3 radians, and it's going to know it's radians because our mode was radians. And when we press enter, we get our answer, negative 7.015, and round it to 3. Okay, so we are going to have 4 decimal places. So it's negative 7.0153 was our 4 decimal places. So we can go ahead and use our calculator now for these types of problems. So finally, I'm going to use a word problem here. So it says a 10-foot ladder leans up against the side of a house. A ladder makes an angle of 60 degrees with the ground. How far up the side of the house does the ladder reach? Find the exact value and the decimal approximation. So when you see exact value, that is a hint that we're not going to be using your calculator, and this can be solved using the unit circle or one of the special triangles. So exact value usually means like square roots, and pi's will be in your answer. Okay, so step 1, we are going to draw a diagram. And for word problems, I do expect that you draw diagrams. So here's our house, and we have this ladder here, and we have the ground, and the ladder makes a 60-degree angle. and we want to know how high up this 10-foot ladder makes. Okay, so this is labeled as 60 degrees. So we have, the ladder makes a 60-degree angle with the ground. We want to know how high up does it go. That is our unknown, and it's a 10-foot ladder along the side. Okay, so if I were to blow this up, I have this, I have 60 degrees, and I have 10. So I'm given an angle, I'm given an opposite, and I'm given a hypotenuse. So I have an opposite and a hypotenuse for a picture. We're going to set up a trig equation to model the situation. So I want to know what trig equation has to do with opposite and hypotenuse. Well, this is a right triangle. We're assuming that this house is erect at 90 degrees to the ground. So we have a right triangle. We're given an opposite and a hypotenuse height. So we're going to use SOHCAHTOA. So using SOHCAHTOA, and I have opposite and hypotenuse, I can use sine. So I know sine of my angle, which in this case is 60 degrees, is the opposite, which is x, over the hypotenuse, which is 10. So here's the trig equation that models the situation. I'm going to solve for the unknown. So to solve for the unknown, I can go ahead and just multiply both sides of the equation by 10. And I have 10 sine of 60 degrees is x. And I can solve for this. I know what sine of 60 degrees is. You can either draw a special triangle. We have the 30, 60, 90 triangle. You know the ratio of the sides are 1/2 root 3 over 2 and 2. So we can solve, and we can also use the unit circle. And if I had to just draw a quick quadrant 1 unit circle here at the 60 degree angle, I know I went over 1/2 and up root 3 over 2. So at 60 degrees, I know sine is the y-coordinate, or y over r, and my r is 1 because it's the unit circle. So I know that sine of 60 degrees is root 3 over 2. So it's 10 times root 3 over 2 equals x, or 5 root 3. So x is 5 root 3, my units being feet. So this is my exact value. And you're also asked to find the decimal approximation, rounded to 4 decimal places. So the approximation with the wiggly lines, it is approximately equal to 8.6603 feet. And step 4 would be to answer the question. And the expectation is that all word problems will have sentence answers including units. Okay, so the ladder reaches about 8.6603 feet. Forgot the 3. Up the side of the house. Okay, so some people ask, is it okay to put the decimal approximation here in the sentence? Sure. As long as I see that you answered the exact value and the decimal approximation somewhere, since it did ask for the exact value and the decimal approximation. I do see them both. The sentence answer, you could have one of them. That would be fine. Okay, so that is all. I hope you have a great night.